I'm currently writing a book on software operability from the perspective of teams. So at SKELTON THATCHER, we do team-first digital transformation. We've got clients in Germany, US, China, UK, and so on. And today's talk comes out of the experience that we have had working with organizations. This is how we see ourselves. This is not literally me, that's not my backside, but this is how we see ourselves in terms of working with organizations. We're inside the engine, fixing it, making it work. Anyway, so today, this is what we're going to be looking at. How and why to design your teams for modern software systems. Why do we care about that? Well, it enables us to produce safer, more rapid changes to software systems. Why do we care about that? It gives us business agility. And there's very few organizations that would not pay for business agility. We're taking a very team-focused approach to this. The team is right at the center, very much at the center of what we're thinking about. We start with the team, not with individuals, not with the technology. And when we think about the team, we need to think about the capabilities of the team, what the team can do, but also the appetite that the team has and how interested the team is in doing things. We need to understand the team's we need to think about the understanding that the team can have about the software, and crucially, the responsibilities that that team has. How clearly are the team's responsibilities defined? These are the kind of things which really make for success in a DevOps, in a modern software delivery context. There's an assumption that I'm making here, though, and this is really, really important. The team is stable, slowly changing, and long-lived. We do not just create a team for a 3-month project and then throw away the team afterwards. The team is so valuable. If a team is high-performing, it's so valuable, we should keep that team. And it should only change slowly. We should also expect, if we add somebody to the team or remove somebody from the team is new. It's a brand new team at that point. So the team is immutable. Okay, we'll start with Conway's law because this is some. I need to cover some principles, if you like, in order to make the rest of the talk make sense. I'll put the rest of the talk in context. Who has heard of Conway's law before? Not very many. About half, maybe. So Mel Conway in 1968 in Harvard Business Review observed this. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. Now that's actually quite radical. The implications of this are extremely radical. Ruth Mallon in 2008 characterized the same observation like this. If the architecture of the system and the architecture of the organization are different, the architecture of the organization wins. So if our organization architecture does not match what we want to produce from software, we'll have a very hard time. Now, more recently, there have been some scientific studies in different disciplines, jet engine manufacture, car manufacture, and in software. Here's one example from McCormack and his colleagues in 2012. And they did some analysis with very strong statistical evidence to support Conway's law. So they found very strong evidence to support this hypothesis that a product's architecture tends to mirror the structure of the organization in which it's developed. So Conway's law was an observation more than a law. Since 1968, and particularly in the last 10 years, we've seen substantial evidence to support this at an analyzable level, statistical level. And it's particularly prevalent in kind of engineering disciplines. So this is really important, because if the way in which our organization is set up does not, is counter or is very unsuitable compared to the types of software we're trying to build, we're going to find it very, very difficult, or if not impossible. There's something here called that Alan Kelly calls the homomorphic force. So homomorphic meaning the same shape. There's a force which tends to push things into the same shape. So if we start with software in a particular shape, that will probably naturally push our organization to adopt the same shape. And the opposite way around too. If our software is in a particular shape, it will probably push our organization naturally into a particular shape too. So this is something to be aware of. Let me give a very simplistic example of what we mean by this. So if we have some front-end developers here in blue, busy with some Node.js application or whatever, and some back-end developers doing some back-end development. Actually, these days it would still be Node.js anyway, but that's, so they're busy doing some back-end stuff. And we've got, in orange here, we've got a single lonely database administrator. It's always a single lonely DBA. Who's a DBA? Who does any database stuff at all? One or two, okay. So you'll know the lonely DBA, right? The implication is if we're building, if this is what our teams are, how our teams are arranged, the natural software architecture that would result is something like this, with a user interface, a UI layer, an application tier, and a single core database. This is very simplified, but this is the implication. So the architecture on all I've done here is to turn the left-hand diagram through 90 degrees to the right. That's all that's happened. This is very simplistic, but this is the principle. So there's something we can look at called a reverse Conway. And that means if we want, for example, some kind of microservices type architecture like this, where service A is independent of service B, each with their own data store, the implication is that we should arrange our teams so we have the database capability within the team. So a database person in that team and no central DBA. That's the, again, this is very simplistic, but this is the implication of Conway's law. Now this is heretical. Like the traditional software architect would want to burn me and other people who talk about Conway's law. They want to burn me like a witch in the medieval period, right? This is heretical. But it does mean that the traditional ivory tower software architect who says, we must design it like this because this is the right way to do it, is kind of missing the point. What Conway's law is really saying is we need to co-evolve the technical architecture with the organization architecture, or potentially even set up the organization architecture first to enable the technical architecture to emerge. So we need to design the organization architecture to produce the right software architecture, which a lot of organizations simply haven't thought about at all. So let me talk a little bit about cognitive load. Cognitive load was defined by this chap called Sweller in 1998, the total amount of mental effort being used in the working memory. Since 1998, there's been quite a lot of research around the effect of cognitive load on individuals and in teams. In particular, there was research in the US Navy with teams of people who work in the Navy, how they work together on a ship, under which conditions does the team start to fall apart or not work as well. There's different kinds of load. There's some load that we try and get rid of. There's load which is germane or relevant, So we can minimize certain amounts of cognitive load, but there's always going to be an amount of cognitive load which we actually want to retain. If you're very interested in the detail of cognitive load, because I can't mention it all here, there's very good talks and blog posts by Joe Pierce, including conference talks. So there's one particular talk called Hacking Your Head. If you search for that, you'll find lots of useful material. The point here is that there's plenty of research and understanding of the principles. It's not very widely known. We've got some science behind it. So there's loads of scientific papers. These slides will be online later, so there's no need to write down the details. But there's several papers here in the middle that were done. The research was done in the U.S. Navy. So there's plenty of evidence and kind of well-structured study. Most of it applied not in a software context yet, although that is happening now. This is a thing to remember, though, about cognitive load and the effect on teams. So stress impacts team performance by narrowing or weakening the team-level perspective required for effective team behavior. It's found by Driscoll and colleagues in 1999. And what that means is, if we ask the team to do too much stuff, if we ask them to take on a subsystem or a component that is too complicated, too complex, requires too much cognitive load, the team itself will start to fall apart, will start to not behave as a team, and then we lose that high performance, that high effectiveness of the team, which we don't want. The implication of this is there is a maximum amount of cognitive load that we should expect a team to be able to deal with, and we should not give them more than that, otherwise we lose the effective team behavior. So this is not just me finding some popular science articles. In the past, I've done some scientific research on in neuroscience. I did some stuff on speech perception, and many years ago, I wrote some software for brain imaging machines. So I have some context for cognition. I'm not an expert, but I do have some additional context for what I'm saying here. So high-performing teams are hugely effective. Much more effective than just a collection of individuals. If we get the team working as a unit, it's extremely effective. So we're looking to optimize for the team. And we need to match the responsibility of the team to the amount of cognitive load that team can handle. That's what we're talking about here. This has some important implications later on. It crucially means that the size of subsystems, the size of bits of system that the team should work on should be dictated by their maximum cognitive load. So we start with what the team can do, and we divide our software system into pieces that are of a suitable size for the team. Several years ago, I started to collect some what I've called team topologies. So these are these Venn diagrams like this, which you may have seen before, which try to express some different ways in which teams can be effective when working together in a kind of DevOps context. And actually, there are some ways in which teams can be very ineffective when working when they're set up in a particular way. So that's what I mean by a topology, a kind of collection of responsibility boundaries, who collaborates with whom and how, and what are they responsible for. So you'll find the collection at DevOpsTopologies.com. First of all, though, we've got some different colors meaning different things. So green is a kind of DevOps-y collaboration activity happening. Yellow is sort of product development, testing. Blue is roughly IT operations. Orange for database. Largely ignore the purple one, which is SRE, we'll say why. The pink for components, and then gray for supporting team. When you see red, that means an anti-pattern, an anti-type, something we want to avoid. There's actually an important team type that's missing. And if you spot it, then maybe you could put your hand, if we got time at the end, maybe you could have a question or what have you. That would be interesting to see if anyone can spot the team type that's missing. It's deliberately missing. So first of all, some anti-types. So here's a classic anti-type. This is why DevOps first came about, because there's a big gap between development and operations. That's fairly obviously a bad thing. Here's the anti-type that Greg mentioned in his talk earlier, where we just have a DevOps team in the middle, and they keep development and operations nicely separated on a permanent basis. It's a bad thing, right? Some organizations think they don't need ops because we've got the cloud now, right? So we don't need any kind of operational expertise, anything like that. And so they just put a little DevOps team inside development, and then they realize that the systems start falling over and it's difficult to monitor them and so on. So that's a bad place to be. Some organizations just run a DevOps team as another development team with a focus on, I don't know, building infrastructure or automating things. And again, that's not helping to bring development closer to operations. It's not helping to identify operational criteria and the way in which the system needs to run. And in some places, the old system administration team, sysadmin team, just renames itself as DevOps because they're writing a bit of Puppet. That, again, it's not very effective because it's not bringing operations any closer to development. And there's a particularly bizarre one here from a person called Matt Franz, where ops, the web operations people, were sitting inside a development team and being managed on weekly sprints with no awareness of the need to react to problems. So that one was really painful. I wouldn't have, that was not my, I would never have imagined that an organization could do something so stupid, but anyway, it clearly did. There's also a gap between development and DBAs. Maybe with the DBA sitting with operations and not really kind of talking to development about how they need to use the databases the DBA support. Maybe this gap is even wider between DBAs and development in some organizations. So there's lots of ways in which we can set things up that are not very effective. So let's look at some ways which are more effective. We can have, so when I say dev, I mean people who are focused on building new things, and ops, people who are focused on restoring service and maintaining live service. We might keep the distinction between these two groups, but collaborate on some things in the middle. So we might collaborate on infrastructure automation, on monitoring, on logging, these kind of things. And this works very well for some organizations or some teams. Some teams effectively have merged the responsibilities almost entirely, and that works very well for them, where we rotate people into operational roles, people who in the past have been used to doing operations, learn how to code in Node.js or in Ruby or something like this. This one seems to work best for organizations which have a single product or single focus, or teams that have a single focus. This can work quite well. It's probably not the best choice for most organizations, but it could work. If you're using, say, Amazon or Azure Cloud, then actually a lot of what has traditionally been done as operations is somewhere else. And the only interaction we have really is through an API key in the middle. Because if you're running your stuff on AWS or Azure or Google Compute, would you have a telephone call or raise a ticket with the Amazon or Google or Microsoft engineers to say, oh, my application's not working, can you help me? No, you wouldn't do that. So the interaction there is it's kind of operations as a service. A lot of stuff is just being removed. There's no need to have that kind of interaction. It's being codified as a service. And in fact, bigger organizations will, many bigger, larger organizations, particularly in retail, so organizations that sell lots and lots of physical products from stores, are adopting this model internally as well. Even if they run their own data centers and so on, they'll adopt this model so that there's no need for collaboration. And this is kind of an important point. We'll come back to this later. Some hosting providers offer a kind of DevOps as a service where they're reaching out for, so in the particular case I'm thinking of is Rackspace, who offer a kind of DevOps consultancy for smaller companies who are not aware of automation and this kind of thing. So the smaller company here on the left who's building some things can have a kind of collaboration that's coming from operations. That seems to work for some organizations. This looks quite like one of the anti-patterns. We've got a team in the middle between development and operations called the DevOps team. But their purpose is to bring development and operations together over a period of time. And eventually they might expect themselves to disappear. We might expect, the people working in that DevOps team might expect to make themselves not needed in several years' time or several months' time. Maybe that team is there permanently, helping to keep development and operations together as a kind of facilitating role. There is a model that Google used called SRE, Site Reliability Engineering, and there's been quite a bit of talk of it recently because there's a new O'Reilly book that's been released. There's a lot of detail here, but the very quick summary is this. Development produce the software to a specification, to an operational specification. When the software meets that spec, SRE take on the software to run it. So when there's a problem in production, it's the SRE team who get called, not the development team. The problem with this model is you need a very high degree of engineering expertise and maturity and organizational maturity, business maturity, because the SRE team have the power to say, no, we're not taking your latest feature. It's not good enough. It does not meet these operational criteria. We're not happy to take it. And they have the power to do that. I've seen very few organizations that have that level of organizational maturity to allow people running things to say, no, we're not going to put it in production. The likelihood is that you do not work in an organization that can make this work. All this would descend, or this would just transform into the traditional DevOps split. Probably. But maybe you're lucky. Maybe you do work somewhere where this can work. I think you should certainly pause before implementing the SRE model. Containers might mean that we need to have less collaboration because we've specified things a bit more clearly. Maybe there's less need to collaborate. We can have a bit of a separation between development and operations, and that's not a bad thing, maybe. I can see it turning again into the traditional DevOps split if you're not careful. In terms of databases, then, we could arrange things so that there's specific collaboration between application DBAs, or application database developers, and your traditional kind of DBAs who run things in production. Explicit collaboration there. Collaboration on schema, collaboration on changes to the schema, reference data, indexing, this kind of thing. Or we might actually set things up so that there's kind of a database as a service, where the lower level aspects are run by the DBAs in ops, things like backups and log shipping and volume management, all that stuff handled as a service. But all of the application level aspects are handled by development teams. So schema changes, reference data, that kind of thing. There's no single right team topology for any organization. We're not looking to get a single magical, this is DevOps. The crucial thing is to recognize that there are many team topologies that are going to be bad for your organization. And in fact, that within your organization, you will have many different kinds of these topologies, depending on what the teams are doing. This is the fundamental choice, really, when thinking about team responsibilities, from our point of view, what we've seen. Should we collaborate with another team that has quite a different focus or quite a different set of skills? Or should we provide or consume something as a service? So this is the fundamental starting point for me. And the benefits of collaboration are that we discover things very rapidly. There are no handoffs. So if we're in a space where need to learn new technologies, we're moving from Amazon infrastructure as a service, from VMs into Kubernetes, for example, something like that. Quite a big change. Collaboration could be massively valuable because we learn things very, very quickly. We avoid handoffs, the many, many unknowns that we're trying to discover. And of course, some organizations run with that kind of model on an ongoing basis because they're pushing the technology all the time, so they're always having to discover things. The downside is that the communication overhead is quite high, so you're paying a cost for the communication in order to get very rapid discovery, learning and discovery. If we're in a space where actually many of the challenges have already been solved, then it can be better to use a kind of service model where we just consume something and we don't need to collaborate. So there's an increased clarity of ownership, who owns what. There's less context needed on each side for what the other person is expecting. But there's a possibility that if a new situation arises, it will slow our innovation. But actually, with a as a service model, within the parameters of what we've defined, we can go very quickly. There's also a couple of other fundamental team types that we've identified. One is a kind of supporting team. So crucially, this is not a support desk. This is a team that supports other teams doing things. It takes away some of the pain. For example, it could be a team that looks after the continuous integration, build, deployment systems. It could be a team that helps. We might have a team in the operations side that helps with machine provisioning or something like this. And we've also got teams that are aligned to parts of the business domain. So in the case of an e-commerce system, it could be one team for payments, one team for my account, one team for shopping catalog. The other thing to point out here is that within this blue infrastructure circle, within there also are some collaboration and as a service relationships too. So we need to expect, depending on our point of view, we might need to drill down and find some more detail on the kind of relationships here. So these are the four team types I just mentioned here. A product or feature team aligned to a business domain segment, a platform or substrate team. So substrate is something I can build on, like a foundation. And they look after that foundational thing. A component team that focuses on one specific bit, and a supporting team. So let me show you how these fit together. So in here, this team in blue is providing a foundation on which the product teams can build. There's four product teams. 3 of the product teams can simply consume what this platform team provides because the platform is entirely suitable for them, provides everything they need. However, this top team here is working on some new discovery. It's this Kubernetes transformation or something like this, and there's value in them collaborating. There's value in these 3 teams here not collaborating in just consuming as a service. It allows them to go nice and quickly. There's value in this team collaborating because they're discovering new things. These 2 teams at the bottom need to consume this component. Let's say the component is, perhaps this organization is building video processing, something to do with processing video. So actually these 2 teams work on a bit of the system that needs to consume some sort of MPEG algorithm or something like that. So they're collaborating with the component team. And then there's some sort of supporting team here that helps to make the 4 product teams as productive as possible. Builds, environment automation, this kind of thing, helping them to discover, helping them to perhaps get started with new technologies or a new way of doing something. And these 4 team types and this kind of thinking, from our experience, is a very good place to start when thinking about the kind of team boundaries and team responsibilities to have in your organization. If you have teams currently that do not fit into this, probably things could improve if you went to a model like this, probably. Obviously, this is it's not that it's simplistic, it's quite prescriptive. But we've seen lots of different teams in lots of different organizations doing different things. And in the most part, if those organizations adopt a model like this, it would help them a lot. And the implication is that actually that will change the software as well. So we're looking for areas that are more complicated to break out as a component. We're looking for ways in which to split the product development into streams that map to the business domain for these yellow, for the product teams. We're looking for opportunities to simplify things and to take some heavy lifting into a supporting team. And we're looking for opportunities to provide infrastructure or platform as a service, whilst also realizing that sometimes we need some collaboration between development teams and operations teams. But we're being very specific about when we have certain kinds of collaboration and when we consume something as a service. This page is a notebook from one of our clients from a couple of years ago. In the financial services sector. They started a DevOps transformation in 2014, and we helped them with the strategy. But I was really pleased to see this diagram because one of the lead people involved had mapped out what he thought was a possible 2-year transformation. So starting with 2 very separate dev and ops teams, they started 2 extra teams. They expected these teams to come together over time. As it happens, it hasn't quite happened exactly like this, but they've made some big progress. The key thing I wanted to call out was that they'd realized that the way the team topologies would change over time, they would evolve, because that would give them new opportunities for doing things. Eric Minnick from IBM put it like this: the goal for a DevOps team should be to put itself out of business by enabling the rest of the organization. So if you currently have a DevOps team that does not expect to not exist in a few years, then have a think about that. So collaboration can help with discovery and rapid learning. That's where the collaboration part really helps. But collaboration is expensive. So actually if we can set things up so that we don't need to do as much of that and can just consume things as a service, we can have highly predictable delivery. And in fact, if you look at the established platforms as a service, you'll find this pattern for predictable delivery. So specifically, Cloud Foundry, Pivotal Cloud Foundry, explicitly within the platform make a distinction between application responsibilities, so in this case, yellow, product development, application, and platform in blue. That's codified into Pivotal Cloud Foundry. That separation of responsibility. And the reason why it's codified there is because Pivotal, or Cloud Foundry, both of them, have done the discovery. They've done the hard work in discovering the awkward aspects of how to run software systems in the cloud. So it's more valuable to have a separation where you've got a clear boundary of responsibility. So that helps to explain the context for setting things up as a service versus collaborating. We might expect the team topologies to evolve as well. In fact, we should absolutely expect that. So here, on the left, we're collaborating really, really tightly together. We're doing some really brand new discovery, brand new technology, really difficult problem domain. But over time, as we discover more and find some useful patterns, over time we might try and move to a point where we've sort of established a way of working, and there's less need to collaborate on that stuff all the time. And so the product teams can consume things as a service. And we can expand it further to the whole organization, or to a wider set of teams. So if this team one here is doing some discovery, when I say team one, this is really a collaboration between two teams. We're doing some discovery. We discover enough so that team two can actually just consume a whole load of stuff as a service. And then they can just use it and go really quickly. But team one continues to discover some things, and eventually team 3, team 4, team 20 can use some stuff they've discovered as a service. And maybe team 1 continues being in discovery mode, or maybe one of these teams here starts to discover some things. And of course, in practice, teams might need to do a bit of discovery alongside some normal delivery. So you'd expect aspects of what that team does to involve some collaboration, some very close collaboration, and other aspects just to be about using a platform as a service. So here's the key thing. So we need to evolve different team topologies for different parts of the organization at different times to match the team purpose and context. So what are the teams trying to do? Are they discovering? Are they trying to deliver very rapidly? We can start to expect how the team topologies would evolve depending on what we're trying to achieve as a business. So this is a summary. I think we're going to finish a little bit early, which should mean coffee earlier, is that right? Okay, that's probably a good thing, right? Okay. So here's a summary. I mean, maybe we'll have a time for a couple of questions. Summary is this. Given Conway's law at the top here, given that Conway's law seems to actually have effect, that the architecture of the organization is mirrored in the architecture of the software and actually drives the architecture of the software sometimes. If we want a particular kind of software architecture, we need to think about the architecture, the architecture of the organization to enable the software architecture to emerge. So design the organization architecture to produce the right software architecture. When we say software architecture, I mean the whole software system, including storage, network, compute, all of the different software services, databases. I don't just mean the software, the application. We need to be aware of the the way in which teams can perform, a sweet spot for a high-performing team, and that loading too much stuff onto a team will start to make the team not behave like a team. That's a bad thing. So think about the total maximum cognitive load that a particular team can actually handle, and match the team responsibilities, what they build, match it to that total cognitive load that that team can take on. Do not expect a team to have to work with a part of a system that is so complicated that they have no idea what they're doing. Split the system into smaller chunks that are team-sized. If you're interested in these team topologies in a bit more detail, there's some additional kind of wording and people have commented and things, then head to DevOpsTopologies.com. You'll find the full catalog of patterns there. There's no single right team topology, but there's definitely some bad topologies for an organization. And as a starting point, take these 4 team types. So product feature team aligns to a business domain segment. They probably don't collaborate often with the infrastructure team, but if they're working on some new discovery things, new infrastructure, new technology, then they would definitely collaborate. The platform team sometimes may collaborate, as we've just seen, but probably focuses on providing IT platform services to the product team. And that can be a challenge, right? Because moving from a model where we just, as an ops organization, as an IT infrastructure organization, instead of just responding to, oh, give me a new VM, give me a new a new environment, moving from that to a model where we build, inside ops, we build infrastructure that can be automated, and we provide a service, and we have a service level, and we're very responsive, and we reach out and ask what our customers need, the product teams. That can feel very different for many people who have worked in operations before. But it makes things effective. Think about a component team. So when we have a part of the system that is very complicated, that needs additional expertise, beyond the expertise that a product team reasonably could have, then that's where we introduce a component. But generally speaking, we should have many fewer component teams compared to product teams. Depending on whose advice you take, somewhere around 8 out of 10 teams should be product teams. Perhaps you'll have 1 or 2 component teams. Something like this, something like that ratio. So the majority of teams should be business aligned. And then some supporting teams which take some of the heavy lifting, some of the load off the product teams, and can help to coordinate some of the architectural and practices across there too. We should expect the team topologies to evolve based on what teams need to do at a particular time. It can be very useful to expect this, in this case, team 1. We say, look, part of your goal is to discover enough so that we can break some things off as a service. That could be part of the definition of success for this team here, is discover enough so that part of this stuff here we can break off and run as a service. So as we said, evolve different team topologies for different parts of the organization at different times, depending on what they're doing, their context. I need to mention something here. Just coming up with some team topologies that address Conway's law and cognitive load, that's not going to give you effective software systems. It's part of the picture, but it's not the only thing you need. And this is what Greg said earlier on. We also need the right kind of culture. We need good engineering practices. We need funding models, so the way in which teams have work paid for, even the way in which teams have their bonuses paid, if you're still using bonuses, hopefully not. But crucially, you need clarity of business vision. If the business or the organization does not really understand why or what it's asking for, then there's very little chance that we as technologists are able to build something that's going to be useful. So the implication of some of this stuff is actually that we have to kind of turn around and talk to the business, people who are asking for these things, and insist on increased clarity, because that will ultimately help them achieve what we need for the organization. So I'm turning this into a book with a colleague of mine, with a clearly fake front cover, right? I did that in PowerPoint earlier on. So this book, we'll be working on this book during this coming 2017. So some of these ideas will be expanded into a book sometime in 2017, if all goes well. So that's all I have. Thank you very much. So I think we have maybe 5 minutes? 4? Okay. 4 or 5 minutes for questions. Does anyone have a question? Apart from, can I go for coffee? Oh, this one here. Oh.
Hi. Doesn't seem to be online. Okay. My question is, what are practical means to measure the maximum cognitive load for a team?
That's a very good question. So the question was, are there practical means to measure the maximum cognitive load for a team? I'm working on that. I don't have a very good answer, because cognitive load, it depends on lots of factors. It depends on the problem domain that you're working on. So if you're working on some complex financial trading algorithm, you probably need people with a mathematics background. So that, for those people who have a mathematics background, the cognitive load will be less than if you give it to someone who's not from a maths background. So again, it depends on the people, it depends on the problem you're working on. So I'm not sure exactly the approach that's useful to take there, because coming up with some hard and fast numbers feels slightly wrong, but yeah, maybe read the book later next year. Yeah, it's a very good question. It's a very good question.
Thanks.
There's a question somewhere over here, was there? Or not? That's all. Is that it? Yeah, that's all I have. So I'll put the slides online shortly, and you'll be able to download them from SlideShare.
Yeah. Question? No?
Same question, actually.
Same question. So.
How to measure cognitive load?
Okay, so you had a question about how to measure cognitive load.
I mean, I understand this is not kind of measurable, but.
So I think one way of thinking about cognitive load is to simply ask the team. Like, if the team is working as a basic unit of people, then simply ask the people there, to what extent do you feel safe and comfortable with working with the system that you're working on? Crucially, if that team is responsible for the runtime success of the system, of the component or the product that they're building, and to be honest, with DevOps, that's where we should be heading. We should align the incentives so that the team that's doing the building should also be running. Then if that team comes back and says, yes, we're happy with this, we understand exactly how this thing works, we're also happy to be on call, to be woken up at 2 in the morning when the thing goes down, then that's a reasonable indication that you've not gone beyond the maximum cognitive load for the team. If actually you ask the team and they say, can you tell me how this thing works? Are you happy with it? What's your feeling about being on call for this thing? And they go, oh my God, there's no way I feel really unhappy about being on call for this system because I have no idea how it works. That's probably an indication that you've gone beyond that barrier. So that would be the first place to start. Great, coffee time. Thanks very much, everyone.